Hello everyone. Today I am here with the important questions of the chapter Surface Areas and Volumes to clear your concepts. Just look into the tips to calculate the surface areas and volumes of combined solid shapes. To calculate the surface area of the combined solid, we should only calculate the areas that are visible to our eyes. For example, if a hemisphere is surmounted by a cone, then to calculate the surface area of the new solid formed, we need to find the curved surface area of the cone and the curved surface area of the hemisphere. We will not include the base area of both the cone and the hemisphere, since when it gets attached will not be visible to us. So the total surface area of the solid so formed will be equal to the curved surface area of cone plus the curved surface area of hemisphere. Now just look into this shape. Here a hemisphere is surmounted on the cube. So to find the surface area of this new solid formed, here we are going to find the total surface area of cube. And from this cube, we will subtract the area that is overlapping. That is, this is the area of hemisphere and this is the area of the top face of the cube. So we will exclude this area of the hemisphere that is attached to the cube. So total surface area of cube minus area of circle, because this area is overlapping. This area is overlapping with the two solid shapes. So that to be excluded, and add with the area which is visible to you, that is curved surface area of hemisphere. So the total surface area of the solid formed will be equal to total surface area of cube. From that we will subtract the area which is overlapping, that is area of circle to be subtracted, plus curved surface area of hemisphere that is visible to our eyes. Now just see for the volume, how to calculate the volume of the combination of solids. To calculate the volume of the combination of two solids, that will be we need to calculate the volume of individual solids. So for this same figure, to find the volume of the new solid, we need to find the volume of the hemisphere plus the volume of cube. So the volume of solid formed will be equal to volume of cube plus volume of hemisphere. To calculate volume is very easy, just you should be very careful while calculating the surface area. Now just see this figure. Here the new solid is formed. From the cylindrical vessel, the hemispherical portion is carved out. So to find the volume of this solid, we need to find the volume of cylinder, and from this we will subtract the volume of hemisphere that is being removed out. So to find volume is not tough. Just now see, to find the total surface area of the solid, here we are going to find the curved surface area, that is outer curved surface area of cylinder. As for surface area, as I already said, we are going to add all the areas that are visible to our eyes. Here, we are able to see this area, that is curved surface area of hemisphere. So that to be added. Curved surface area of hemisphere. So this is the difference between while calculating the volume and the total surface area. So for volume, the object that is being removed to be subtracted. But for calculating the total surface area, we add all the areas that are visible to our eyes. Next, to find the volume of this pencil, here just see that here we are able to see the cylindrical portion and the conical portion and this circular base. So the volume of this pencil will be equal to volume of cylinder plus volume of cone, that is this one. So now to find the surface area of this pencil, total surface area of this pencil, we will add all the areas that are visible to our eyes. So here we are able to see the curved surface area of this cylinder. So we will find the area of this cylinder. Then we are able to see the curved surface area of this cone. So add this curved surface area of cone. And we are able to see this base, circular base of the pencil. So that also to be added, that is area of circle. So this will be the total surface area of the pencil. So just now see the next figure. For this figure, to find the volume, it is volume of cylinder plus volume of one hemisphere and the volume of the second hemisphere. So volume of two hemispheres. Now to find the total surface area, of this solid, so we are able to see whatever the areas we are able to see, that to be added. That is the curved surface area of the cylinder plus the curved surface area of the two hemispheres. Hope this concept is clear to all of you. Let's have the recap of the formulae. Curved surface area, total surface area and volume of different solid shapes. So the curved surface area of cube, where the side is A, is 4A square and the total surface area is 6A square and volume is A cube. Curved surface area of cuboid is 2 into L plus B into H and the total surface area of cuboid is 2 into length into breadth plus breadth into height plus length into height and the volume of cuboid is length into breadth into height. So the curved surface area of cylinder is 2 pi r h and the total surface area of cylinder is 2 into 2 pi r into r plus h and the volume of cylinder is pi r square h. The curved surface area of cone is pi r l, and the total surface area of cone is pi r into r plus l, where l is the slant height equal to root of r square plus h square, and the volume of cone is 1 upon 3 pi r square h. The curved surface area of sphere is 4 pi r square, and the total surface area is also 4 pi r square, and the volume of sphere is 4 upon 3 pi r cube. The curved surface area of hemisphere is 2 pi r square, and the total surface area of hemisphere is 3 pi r square, and the volume is 2 upon 3 pi r cube. So now to find the length of the diagonal of a cube, so it is root of a square plus a square plus a square, where a is the edge of the cube, so which is equal to root of 3a square further equal to root 3 into a, that is root 3 into side. So the length of the diagonal of a cuboid is equal to root of length square plus breadth square plus height square. So these are the formulas of surface areas and volumes. Let's solve the questions. If the total surface area of a solid hemisphere is 462 centimeter square, find its volume. So here what is given? Total surface area of a hemisphere, that is 462 centimeter square. So we need to find the volume, but before that just apply the formula of total surface area of a hemisphere, which is 3 pi r square, which is equal to 462. Put the values: 3 into 22 upon 7 into r square equal to 462. Cancel it. So cancel with 22 also. So r square will be equal to 7 into 7. Then r is equal to 7 centimeter. So we get the value of the radius, that is 7 centimeter, and we need to find the volume. So volume of a hemisphere is 2 upon 3 pi r cube. Volume of hemisphere is 2 upon 3 pi r cube. Put the values: 2 upon 3 into 22 upon 7 into, and the radius is 7 into 7 into 7. So cancel it. So we get here 44 into 49 upon 3. So when you multiply 44 into 49, you get the value as 2156 upon 3. Divide and write the answer. You'll get 718.67 centimeter cube. So this is the volume of a hemisphere. Next question. Two cubes each of volume 27 centimeter cube are joined end to end to form a solid. Find the surface area of the resulting cuboid. Since two cubes are joined end to end, So where the volume of each cube is given as 27 centimeter cube. So here the volume of cube is equal to 27 centimeter cube. And you all know the formula of volume of cube, which is side cube is equal to 27, and we know that 27 is a cube of 3, so it is side cube is equal to 3 cube, where side is equal to 3 centimeter. So now with the help of this side, if the side of one cube is 3 centimeter and the side of the other cube is also 3 centimeter, so here the length of the cuboid will be 6 centimeter, and here the height of the cube is 3 centimeter and the width of the cube is 3 centimeter. So now we get the values. Length of the cuboid is 6 centimeter, height of the cuboid is 3 centimeter, and the breadth of the cuboid is again 3 centimeter. So we need to find the value of surface area of the resulting cuboid. So the formula for surface area of cuboid is surface area of a cuboid is equal to 2 into length into breadth plus breadth into height plus length into height, which is equal to 2 into, put the values here, length is 6 centimeter and breadth is 3 centimeter plus breadth is 3 and height is 3 plus length is 6 and height is 3. Solve it. So it is 6 into 3 is 18 and 3 into 3 is 9 and 6 into 3 is 18. So we get 18 plus 9 plus 18. So it is equal to 2 into 45, that is equal to 90 centimeter square. So this is the surface area of the resulting cuboid. Let's move to the next question. The sum of the radius of base and height of a solid right circular cylinder is 37 centimeter. If the total surface area of the solid cylinder is 1628 square centimeter, find the volume of the cylinder. So here what is given? The sum of radius plus height is given here as 37 centimeter, and here the total surface area of the solid cylinder is also given, that is 1628 square centimeter. So the total surface area of the cylinder is 2 pi r, wait, right, what is given first? Total surface area of a cylinder is 1628 centimeter square. This is given. We know the formula. Total surface area of cylinder is 2 pi r into r plus h, which is equal to 1628. So put the values. 2 into 22 upon 7. Since we don't know the radius, so write it as r, and the sum of r plus h. Sum of r plus h is 37 centimeter. So write here as 37 equal to 1628. So cancel it. Cancel this also. So here we are left with 1. So radius will be equal to, shift this 7 to the other side. So radius is equal to 7 centimeter. So we got the value of the radius and we need to find the volume of the cylinder. Since the sum of the radius and height is given here as 37 centimeter, so where radius we found as 7, so put the value of radius in this equation. R plus h is equal to 37. So radius is 7 plus h is equal to 37. So height will be equal to 30 centimeter. So now you find the volume of cylinder. Volume of cylinder is equal to pi r square h, where pi is 20 upon 7 and radius just we found that is 7 centimeter. So r square is 7 into 7 and height is 30. So cancel it. So we get 154 into 30. Multiply and write the answer. So it is 4620 centimeter cube. So this is the volume of cylinder. So the next question. A solid wooden toy is in the form of a hemisphere surmounted by a cone of same radius, where the radius of hemisphere is 3.5 centimeter and the total wood used in making the toy is 166 5/6 centimeter cube. Find the height of the toy. Also find the cost of painting the hemispherical part of the toy at the rate of rupees 10 per centimeter square. So from this question we come to know that the toy is made up of a cone and a hemisphere whose radius is same, that is 3.5 centimeter. So we need to find the height of the toy where the volume of the toy is given, that is 166 5/6 centimeter cube. So let's solve. Volume of the toy is given as 166 5/6 centimeter cube. Since the toy is made up of the cone and the hemisphere, so the volume of cone is 1/3 pi r square h plus the volume of hemisphere is 2/3 pi r cube, which is equal to, so do convert this mixed fraction to improper fraction. So how we convert? Multiply this 166 with this 6 and then add 5 to it. So and divide by 6. So we get here as 1001 divided by 6. So replace the values of pi and the radius. So 1/3. Okay, before replacing the value, just check. In these two terms, what is common? So in these two terms, we observe that 1/3 pi r square is common in both the terms. So from this term, h is left, and from this term, 2r is left, which is equal to 1001/6. So now replace the value 1/3 into 20/7 into radius is given as 3.5. So r square will be 3.5 into 3.5 and height is not given. So we need to find the height. So 2 into radius is 3.5, which is equal to 1001/6. So cancel it. So when we multiply 22 with 0.5, we get 11 into 3.5. Cancel this 3 and this 6, we get 2 here. So it is h plus 2 into 3.5 is 7 equal to 1001 upon 2. So cancel this 1001 with this 11. So we get here as 91. So 3.5 into h plus 7 is equal to 91 upon 2. So let's remove this decimal and bring 10 down. So cancel it. 5 2s are and it is 5 7s are. This 2 and this 2 gets cancelled, and this 7 and this 91, it is 13 left here. So h plus 7 is equal to 13. Then the value of h will be 13 minus 7, that is equal to 6 centimeter. So since we need to find the height of the toy, so where height of the toy is height of the cone plus the height of the hemisphere. So height of the cone just we found, that is equal to 6 centimeter, and height of the hemisphere is the radius of the hemisphere, that is 3.5 centimeter. So just let's replace. Height of the toy is height of the cone plus the height of the hemisphere. So the height of the cone is 6 centimeter, and the height of the hemisphere is the radius of the hemisphere, that is 3.5 centimeter. So when you add, you get the value as 9.5 centimeter. So 9.5 centimeter is the height of the toy. So now we need to find the cost of painting the hemispherical part of the toy at the rate of rupees 10 per centimeter square. When it comes for painting, then we need to find the surface area of the toy. So before finding the cost, we will find the surface area of the toy. Surface area of toy. Wait, I think they have asked us to find the cost of painting the hemispherical part of the toy. So just painting this portion. So that is, we need to find surface area of the hemisphere. Surface area of hemisphere is equal to 2 pi r square. So it is 2 into 20 upon 7, where radius of the hemisphere is 3.5. So r square is 3.5 into 3.5. Cancel. So here we get it as, when you multiply this 2 with 0.5, you get 1, and then 22 into 3.5 will be equal to 77 centimeter square. So the cost of painting, since the cost of painting is given here as rupees 10 per centimeter square, so where the area is 77, so the curved surface area of the hemisphere is 77, and the cost of painting is rupees 10 per centimeter square. So it will be 770 rupees. So this is the cost of painting the hemisphere. Let's move to the next question. So question number 5 is, a cubical block of side 10 centimeter is surmounted by a hemisphere. We need to find the largest diameter that the hemisphere can have. So let's draw the cube first. Here the cube is given whose side is of 10 centimeter. And a hemisphere is surmounted on this cube. So let's draw the circular base of the hemisphere. So let us see what will be the diameter of the circular base of the hemisphere. So I think you're able to observe here. The diameter of the circular base of the hemisphere is equal to the side of the cube, that is 10 centimeter. So this is the hemisphere. Diameter of the hemisphere is 10 centimeter. Then the radius is half of the diameter, that is 5 centimeter. So here, as I've asked you to find the largest diameter that the hemisphere can have if it is surmounted on the cube. So the largest diameter of the hemisphere is 10 centimeter and the radius is half of the diameter, that is 5 centimeter. Now the next question is, find the cost of painting the total surface area of the solid so formed at the rate of rupees 5 per 100 square centimeter. So to find the cost, we need to find the total surface area of the solid so formed. Total surface area of the solid so formed will be equal to total surface area of the cube plus third surface area of the hemisphere minus, we are going to subtract the circular portion of the hemisphere which is covering the top face of the cube. And if you observe, we will not be able to touch this circular portion of the hemisphere because it is covering the top face of the cube. So this portion, that is pi r square, we will not be able to touch. So that to be subtracted. That is area of circle. So write the formula here now. Total surface area of the cube is 6 side square plus curved surface area of hemisphere is 2 pi r square and the area of circle is pi r square, which should be subtracted. So let's put the value. So 6 into side of the cube is 10 centimeter. So side square is 10 square plus, solve this first, 2 pi r square minus pi r square is pi r square. So which is equal to 6 into 10 square is 100 plus the value of pi is 20 upon 7 and radius of the hemisphere is here 5 centimeter. So r square will be 5 square, which is equal to 600 plus 22 into 25 upon 7, that is equal to 600 plus multiply 22 with 25, you get 550 upon 7, which is equal to 600 plus 550 upon 7 will be equal to 78.57. Add both the terms, you get 678.57. So 678.57 is the total surface area of the solid so formed. Now we need to find the cost of painting, where the rate is given here as rupees 5 per 100 square centimeter. So cost of painting is equal to total surface area of the solid so formed, that is 678.57, and multiply with the rate given here. So rate given is rupees 5 per 100 square centimeter. So we get, multiply the numerator, we get it as 3392.85 divided by 100. So now when we solve it, we get 33.9285. Now round up and write the answer, that is 33.93 rupees. So this is the cost of painting the surface area of the solid so formed. Now rest of the questions will be covered in the next video. Stay tuned. Do subscribe the channel and share the video with your friends. Thank you.